Welcome to Software Engineering Daily. Between the highly technical world of software engineering and the world of business journalism sits Derrick Harris, a researcher at Mesosphere. In our interview, Derrick draws on his broad array of experiences in history, from his past work at GigaOm to his present career at Mesosphere, a company building the Datacenter Operating System. But before we get into the interview with Derrick, we're going to talk about the sponsors who make Software Engineering Daily possible. Engineers love automation, and Wealthfront automates your investing. As a software engineer, there are certain processes that you want to execute no matter what, like integration tests during a build. You wouldn't execute integration tests manually. You would use a continuous integration tool like CodeShip or Jenkins to automate your integration tests. Wealthfront is a tool to automate investing. Just like a continuous integration tool runs your tests automatically, Wealthfront can reinvest your dividends automatically and perform tax loss harvesting automatically. To get your first $15,000 managed by Wealthfront for free, go to wealthfront.com/sedaily and get started with Wealthfront's layer of automation on top of your portfolio. Wealthfront.com/sedaily. Check it out. It would support Software Engineering Daily, and you will get $15,000 managed for free if you sign up. Automate your investing. Get back to the things that you can't automate, like writing code. Derrick Harris is a senior research analyst at Mesosphere, makers of the Datacenter Operating System based on Apache Mesos. Derrick has worked as a technology journalist for more than a decade and has experience covering big data, infrastructure, and artificial intelligence. Derrick, welcome to Software Engineering Daily.
Hi, thanks for having me.
You used to be a software journalist, which is my current job, and I think your current job is somewhat similar in some ways, but what were your goals as a software journalist?
That's a good question. Aside from keeping my job, my goals were, what I always tried to do as a journalist was to, I think, covering software and covering, as I did covering kind of quote unquote cutting edge software, you're given the opportunity, I think, to play a role of just, what I always try to do is highlight what I thought was interesting, right? Or highlight, what the big trends were. I think it's a lot. It can be a lot different than, say, if you're a technology journalist and your beat is covering Silicon Valley startups and funding and all these things, right? You're always looking for a scoop. You're looking for, who's doing what. But when you're covering the technology, for the sake of the technology, often I think it's really kind of fun, because what I always try to do is like, okay, what am I seeing that's interesting? What's cool? Why is it cool? And doing and trying to give that to readers versus like, kind of, well, so and so. That's part of the job is to cover the business of it, I guess. But the technology, to me, was always a little more exciting
than the gossip.
Yes. Well, yeah.
So did you see your role as explaining technology products to other technologists or lay people?
At GigaOm, I don't suspect a lot of readers would be what you would call lay people. I think it was a lot of, I think it was technologists. I think it was investors and executives. We were fortunate to have a pretty high level readership. C-level type people and VP level type people. So yeah, it was just kind of to tell, people with obviously some very, with a vested interest in the space, right? But no one can keep up with everything that's happening, right? So you try to be that gate, that filter, right? To kind of distill down, to filter out the noise and then distill the stuff into kind of readable pieces. So
do you think that there's room for journalism sources that are more mainstream, things like Wired or TechCrunch? Is there room for these outlets to become more technical or more serious, or is that just like not what their audiences want?
Yeah, I mean, that's a really good question. I happen to think there is room for them to do that. And I don't know. I mean, Wired is Wired. It does what it does, and it does it pretty well most of the time. And I don't know that the Wired audience is necessarily the one, but I mean, there are definitely other outlets. I worked at Fortune briefly, and some other places where there's enough. The business of technology and the technology of technology are kind of converging, if you ask me.
Yeah.
And I think there is definitely a space for some publications that maybe haven't had a strong tech, that don't have, decades of technological, or, what you might call technical debt, I guess, in the software space, right? I mean, that don't have to overcome all that, and they can look at things with fresh eyes. And I think, what GigaOm did was very much said, we're going to cover, it's not going to be like reading a white paper or reading some sort of, a research paper, but it is going to be a little more technical, because there's definitely, how many people work in technology, right? in this country and in Silicon Valley alone, there's plenty of readers who care to read more than just like, the very high level of something.
Well, so I think about like the finance industry and CNBC, and like finance became very sexy at a certain point in time, and then you got this kind of mainstream channel that is CNBC. But CNBC does some stuff that's like pretty in depth, pretty like technical from the finance perspective. I could totally see that go, like you said, the technology of technology and the business of technology are converging. So maybe there's some midpoint in between those where the mainstream will start to head towards, once they realize, if we want to better serve our business audience, we have to teach them technical stuff, or we have to talk about technical stuff on a more technical level.
Yeah, I think so. I mean, I don't believe, some people seem to think that if you have a high level audience that they're, I don't want to say stupid, but like that they can't get it or they don't have the time to. But really, I think just there hasn't been an effort to do it. And I think a CEO, for example, or, certain executives, they're reading about this so much now, and they're hearing it so frequently, how important technology is and how software is eating the world and all these things. And they get it. They really do. Right. And I think at some point you have to take that discussion a little further or a little deeper and take it away from just like, okay, I'll leave that to someone else. Because, you might actually want to know or, have some educated opinions on what your company should do. And furthermore, like there's just, I just happen to believe there's a whole audience of underserved people who work in the tech space and who would like to see, who would like that sort of material. I mean, it's a whole industry that we kind of, the mainstream kind of looks at as over there, like these are the technical people and we're the mainstream people, but there's millions of them. The software industry is worth billions of dollars in the tech industry overall, right? And I would just listen. It's a readership waiting for the right sort of content, I think.
Well, even as a software engineer, like when the earlier years of my career, when I was just working on, run the business Java applications, and that was my, if I wouldn't have done any external searching, that would have been my only conception of what software engineering is, just this Java stuff, maintenance. But thanks to certain media channels, certain like sophisticated media channels, I learned that there are different avenues of software engineering and software. And then the more I explored that space, the bigger the gap I realized between what there could be and what there actually is. Anyway, so let's, I'm curious, like, were you ever tempted to become an engineer, or have you always been in this software journalistic type of role?
Well, I mean, so my education is a bachelor's in journalism and a law degree. So engineering isn't really education-wise hasn't been, a path I've ever really pursued. But I've been tempted certainly to learn to code, right, and to definitely learn parts of the technological a part of what I do. On the other hand, I think with anyone, it's kind of like you have your career, and if to be good at it requires spending a significant portion of your energy on
focus.
And so, yeah, I mean, the idea that, I happen to think I don't want to be a naysayer, right, or a skeptic, but like, the idea that you could take a couple Coursera classes and do whatever and become a competent software engineer or programmer is ludicrous, and to some degree, right? Because people who are good at this, that's all they do. They live, they eat, sleep, and breathe. They eat, sleep, and breathe that, right? So I don't think like it's not. Yes, I mean I have a working understanding of obviously of how stuff works, but yeah, no, it's and yes, I've been tempted to consider it, but it's like, well, am I willing to quit my day job and study this? Because
did you get this understanding of like data center operating system and all the data center operating system is like, that's a concept that requires so many other things to kind of begin to approach, like, for example, in order to understand compilers, right? Like, did you just read the Wikipedia article on compilers, or like, to what degree do you feel you have to understand how code works and how technology works?
Well, the great thing about being a journalist, frankly, is that you can, a lot of times you can just ask people how things work, right? And so, I mean, I was fortunate enough that when I graduated from college, my first job was, and I had no computer science experience whatsoever. My first job was covering grid computing and high performance computing. And so I would spend all day reading and writing about, these like big research, Globus and TeraGrid, and these big research efforts back in the early 2000s, and speaking with, these professors and other academicians who were running these things. And I learned, you just start to pick things up over time, right? And that was kind of a trial by fire, but I mean, I can't count, the number of hours I've spent speaking with really smart people, like, and reading papers and reading documentation and all these things. You start to pick it up over time. I mean, it's been now, 12 years, 13 years, like, you kind of, over that amount of time, I guess you've seen so much more than you might realize, or heard so much more.
Interesting. Do you have any like tips or techniques? So like, I am a software journalist at this point, and, many of the times when I'm trying to research a topic or understand a topic, it's like, yesterday I worked on studied some crazy front end technology, and, today I'm doing something that's in the back end, like Spark. And as I'm going from place to place and trying to understand and comprehend these different technologies and figure out the right questions to ask, it's really hard to know where to delve further and where to just say, okay, I'm going to leave that as a known unknown. Do you have any tips for like dealing with that?
Yeah, I mean, I think it helps to know your audience, first of all. So my audience has never been one where it's like, where people would come to look to anything I was writing, expecting, I think, to read like a how-to manual, right? Or like a very deep dive into, the inner workings of a technology. I think, I always looked at it as like how deep, I mean, there's a level of how deep even you understand it and how deep you're willing to write it. Because, for certain audiences, it's lost, right? I mean, especially if you're publishing something online, for a web audience, under what you might call a news publication or a news outlet or anything other than a technical outlet. I think this is expected that there's a higher level conversation, right? And I kind of always try to focus on, A, here's where the technology is cool, but then B, here's why this is important to you for, this business level reason, right? Or here's how it's connected to the other 5 things that you've been hearing about for the past 2 years, right? And I think, I think there's some of that bigger picture discussion is where I've always focused my energy. So it really depends on the audience. So, I mean, obviously there are outlets where, people really want to dive deep and have a serious conversation about the technological merits or the shortcomings.
Sure. Okay. So let's talk about Mesosphere. What is Mesosphere?
That's a great. Well, Mesosphere is a company.
I know that.
So, and a layer of the atmosphere, I'm told. The our so Mesosphere is essentially, the core of our product, like you mentioned, is called the Datacenter Operating System. The core of which the speaking in OS lingo, the kernel of which is Apache Mesos, and that handles a lot of the scheduling and resource aggregation and allocation. And then, on top of that, and you can go and read, any number of Mesos case studies or use cases, right, from some of the biggest companies in the world, including Apple, right? So that part of it is solid and known. What we've done on top of that is create what we call this operating system, which is to say, here is, an analogy we like to use is like Linux is to Android, Mesos is to the DCOS. We're trying to build, and we think we have built a higher level, more abstracted way to build applications, to build modern applications, right? So we built a technology called Marathon, which is for running long running applications. Use it for container management, that sort of thing. Add some high availability. We built Kronos for batch. Actually, Kronos was built by our founders at Airbnb, but they were at Airbnb, but for scheduling batch jobs. So we built, we connect into all these other applications. We have service discovery and load balancers, and we connect into other applications and frameworks and whatever, right, to really give you this full OS experience. And then, of course, there's a user interface attached, higher security. I'm just rattling off like a marketing spiel at this point, but I mean, think about the things when you think about a product. Essentially, when you think about an operating system and a productized operating system, right?
Sure.
That's the kind of thing we're trying to deliver on top of Mesos, which is essentially the kernel of this thing.
Can you describe in more detail what are the responsibilities of the Mesos kernel versus the DCOS?
Well, yeah, I mean, so the Mesos kernel is. I mean, the Mesos kernel, like I said, handles, the real resource level scheduling of stuff, right? So it's going to decide, it's going to aggregate your resources, right? So it's going to take your, let's say, 1,000 CPUs and whatever terabyte of RAM and turn that into a pool, right? And then it's going to, it will allocate where. It will decide where any given framework that you're running on top of Mesos wants to run. That'll be, let's say you're running Spark and Marathon, and you could run Kubernetes, you could run whatever things you want to run, right? I mean, Mesos is deciding where those are running, where there's room for them, right? And handling the resource isolation, that part of the job. The DCOS is really where you say, okay, one example, I want to install a new service, right? Well, so you use the DCOS command line interface, let's say, and you're installing this thing in 4 words, DCOS package install. Let's say you want to do HDFS or Kafka, right? And just insert Cassandra, just insert your package afterward, right? There's the user interface, right? So you want to take a look at where, which of your services are running, how fast, what the performance is. Get some service or some server level or some resource level metrics. There's a user interface for that. There are various other features, tied into that. There's security authentication. There is.
So tell me how glossy of an understanding this is, but so Mesos is, as you said, the kernel, and it's doing the lower level resource management, and the scheduler, the Marathon scheduler, is the Marathon scheduler the interface between the Mesos resource allocator and the other frameworks? So if Spark wants to do something using the underlying resources, does it have to go through Marathon?
No, it doesn't. Well, Marathon, what a lot of people use Marathon to do is to run, I guess it's sort of longer running services that require, Spark, you might spin up a Spark cluster on the DCOS, run your jobs and then kill it. Marathon is usually for longer running sorts of applications. You could host a web app, a JBoss or a Ruby app, let's say, on and run that on Marathon. It's going to run on there. Marathon's actually a meta framework. There's a concept of frameworks in Mesos, right? So Spark would be a framework, Cassandra would be a framework, Marathon would be a framework, and Marathon is kind of a meta framework in that it's able to launch anything on top of it. It's kind of confusing. You have to go, but Marathon you could launch another Mesos cluster on top of Marathon, for example, and it would run that as another. So Marathon does not have to be part of it. We think it's a valuable part of it. If you look at a lot of companies, what they're doing is they're using Marathon as a container orchestration layer. So you're able to deploy and manage your Docker containers using Marathon. Mm. So that and they're building a platform as a service layer on top of that. That's what Yelp did, what Autodesk did, what a handful of other companies have done. So, but then Twitter runs without using Marathon, right? So it's really, I mean, the nice thing is it's modular, so you can pick and choose which parts of these you want to use. But yeah, Marathon is not necessary, but we think it's valuable, and certainly a lot of users are finding a lot of value in it.
Engineers are always looking to simplify. To simplify testing and deployment, engineers turn to CodeShip. CodeShip is continuous integration and delivery as a service. With CodeShip, your tests are executed against your code automatically whenever you push to GitHub or Bitbucket. On Software Engineering Daily, we've done several shows about DevOps, and continuous deployment is key to DevOps. It's a great way to break down the wall of confusion between development and operations. Managing your own testing infrastructure is painful. That's why you want a service like CodeShip to do it for you. If you have a huge number of tests, you can use CodeShip's Parallel CI to run all your tests in parallel. CodeShip will spin up containers on their own infrastructure to run your tests in parallel. If the code passes your tests, CodeShip will deploy it automatically to your users. Companies like Product Hunt are already using CodeShip to speed up and simplify development. To sign up for free and start shipping today, go to codeship.com. Or to try out CodeShip's new Docker platform, go to codeship.com/Docker. Okay, so you've said that Mesosphere is a new platform, but the same technologies that you came to love covering as a journalist. What are those technologies that you came to love covering?
Well, I think I think it's more the concepts, let's say. So, like I said, when I started as a journalist, I was covering grid computing a lot, right? And some of the ideas of that are, inherent in this, right? The idea of aggregating a pool of resources. I always thought when cloud computing, the major promise of cloud computing was not that you would you would just provision a new server, but it would be done remotely, right? The ideas of how you build new applications need to change, right? And and we kind of took, I think, I would say that let's say in 2000, whatever, before Amazon Web Services, essentially, somewhere between 2004 and 2006, 2007, we were kind of making progress in this idea that this is what new resource management was going to look like. This is what your infrastructure was going to look like. It would be a cloud or a pool of resources, and applications would, get what they need and kind of be isolated. And, so the same idea of how Mesos or the DCOS handle resource management. But what happened is then Amazon Web Services came along, and it made provisioning servers, just the same type of server you always used to get, just so much easier. I think we kind of took a step back.
And we said, interesting.
Okay, well, forget about all that for a while, because now we can put it, we can give our credit card number, just spin up servers like IT. That whole idea of not wanting to go through IT for every little thing was kind of solved. And then, it kind of, but then, not to be long-winded, but then soon enough, these new application architectures started shaping up, because people were like, and Netflix helped, I think lead a lot of thinking around this, like, wow, think of all the amazing things you can do because of how easy it is, and how these, how the API access, and how you can control, this new kind of level of control you have over your resources. And then, slowly but surely containers came and whatever, and we made our way back to this. And I think we're finally there now. All these things have coalesced So virtualization, cloud computing, grid computing, containers, all these things. And I think Mesosphere tapped into, the in my mind at least, which is why I went to work for the company, the best way that I've seen of really presenting this as a way to just harness all of these things that we've been talking about for the past decade.
Yeah, you've said Mesosphere is trying to help companies manage their infrastructure, applications, and services how Google and Facebook do. So what are the aspects of Google and Facebook infrastructure that Mesosphere is helping to democratize?
Yeah, so I mean, I think the primary thing is that they're automated, and they're, so it's kind of automation, scale, all these things you might hear about. One of the things that I think is kind of funny is for years we talked about, of course you'd want to buy servers from Amazon, you want to buy servers from Google, right? You want to buy these resources, but the reality is that a lot of people want to run their own data centers, and they want to run like those companies do. They want to use the same design principles, and that means, for example, I mean, if you look at Google and its kind of famous Borg system for resource management, right? I mean, that's a cluster. It's not unlike Mesos in a lot of ways, at least at its foundational level. Like you have a big pool of resources, and developers are writing against that. They're essentially saying, what level of resources their things need, and they're deploying them in some way, right? It takes down. So you have fewer operational. You have a need for probably, I don't want to say fewer, but your operational overhead is a lot less because the system is not designed on a server by server basis. It's a pool, and it's expected that some things are going to fail, right? Some nodes are going to die, and so what I'm saying is I think it's an easier way of thinking about this instead of Google managing 1 million or Facebook managing 1 million servers, right?
Yeah,
I mean, they are technically, they're managing one big ass computer, and everything is written against that. So I think it makes life a lot easier for developers, which is one thing we're definitely seeing. Software architects and the engineering folks are going, okay, we're going to do continuous deployment, continuous integration, and all these things, and container launch, do Docker, and we're going to use Mesos as the basis of it because it just makes it so much simpler to manage and to envision the infrastructure in that way. So go ahead.
Speaking of envisioning the infrastructure, part of the work that Mesosphere is doing is building this great user experience, this great UI, the type of user experience that people would expect from smartphones and web apps. And what are the challenges that come from building a great user experience for the data center?
Well, I mean, our design team would probably, our obviously our front end team would have more perspective on this. But my take, I mean, from what I grasp and just kind of, just my thoughts on the matter is that I think one, you have to think about it in the sense of if you're talking about a large scale data center, how you can't just put whatever 50,000 servers on someone's desktop screen, right? And be like, okay, here's how they are looking, right? It's not that simple, right? So, I mean, distilling a large, complicated infrastructure down into digestible visualizations, I think that's really important. I think just getting showing. You have to show people what they need. Like the first screen is to show someone whatever, the 80-20 rule, right? Show the majority of people whatever they need, what they're going to need to see. And then you have to make it intuitive enough to dive down and drill into this at a more nuanced level or at a more personalized level. And I think, historically, right, it's been, systems management. So I'm not that this is systems management software per se, but that's been kind of, I think not a very nice user experience. It's been kind of, everything was kind of been ugly and very rigid. Like this is what you can see. This is how you see it. And I think we're trying to make that a much more, everyone says like the Google, the Google experience of X, right? But I think that's a fair comparison in some way. Like, what do you need to see now, and how easy is it to find out what else you need to find out?
Right. Okay.
And
that makes sense.
And I mean, and doing that is just something that I don't think has been done at this scale before. No one has come and said, how are you going to look at how, let's say 4 dozen distributed systems are running across this other, 10,000 servers, for example, right? Like that's a much more realistic thing that happens now. And I don't think there's been a lot of effort, aside from what we're doing to say, how are you going to help someone kind of visualize this and monitor it?
So zooming out, Mesos and Spark and Tachyon are all these tools that came out of the Berkeley Amp Lab, and each of them are having companies built around these technologies. And on Software Engineering Daily, we've done some shows trying to grasp the implications of these different new technologies. And I'm really curious if you have any perspective on how these things shift the big data stack, or what would formerly have been called the Hadoop stack. Now there's not so much Hadoop left in it. Can you give your views on how these things are changing because of this Berkeley stack of technologies, Mesos, Spark, and Tachyon?
Yeah, certainly. I mean, if you talk to anyone today, and including the Hadoop company, the former Hadoop company, quote unquote Hadoop companies, Spark is, like the de facto system for all of their batch processing and increasingly stream processing, right? So essentially, if you're processing data, there's a good chance you're looking at Spark right off the bat, right? I think that is definitely a big deal. And Tachyon, I mean, I haven't heard a lot of Tachyon in the wild stories yet, frankly. However, it's exciting. And one thing I think, just the Tachyon Spark connection. I think one thing that you could realistically see happen is, in a decade or so, a group of companies that start as startups or small businesses and grow, and they never really even have to worry about hard disks. Like you say, HDFS is a core of Hadoop right now, and that's very true. And HDFS is the one thing, no matter what happens, like that's where all the data is. However, if you're a small company and you can fit your data in memory on Amazon or wherever, and it's relatively cheap, and memory prices continue to drop as your data grows, and the performance is so much better, and Tachyon matures, and all these things, and Spark runs so much faster in memory, and that's sort of doing your data processing anyhow. Like conceivably, there's not a lot of need for these big sort of a sort of a hard disk right now. And frankly, I mean, even on Amazon right now, you can't get a spinning disk. You can get an SSD and memory and RAM, right? And I think so I think that's going to be a big change over time, just as you see, in memory databases and processing and whatever. So I think that will be one thing, just on the straight up, like, what happens with storage and what happens with Hadoop. I think you'll see a lot, conceivably, the next generation of companies are just like, well, whatever, we're going to do everything in memory because it's cheap enough to do it. And the other thing is that, and where Mesos comes into the picture is that it makes it so much, for big data particularly, it makes it so much easier to install these things. Like I wasn't joking before. I mean, when you type DCOS package install Spark, it installs Spark. Like that's not, it installs in minutes, probably. That is not the usual Spark installation experience, right?
Yeah, I think I heard at Airbnb when they first were getting Spark up and running, Spark or Storm, whatever their first, it took like 2 or 3 weeks or something, like just to get this stuff wired up.
And that was Airbnb, where they had some pretty smart people on the engineering team.
Yes.
So yeah, I think that's going to be a kind of a game changer, frankly. Mm-hmm. And I mean, we have a product, not to pitch too much, but we have a product that we're building called Infinity, which we announced in August, and it's at present, as presently constituted, Spark, Cassandra, the akka framework, and Kafka. Right. I mean, so what you need to build, let's say, an Internet of Things application, right? You have, and a database, real time database processing, and then Spark or Kafka is kind of the message queue in there, right? And I mean, the goal is that installs as a fully operational data pipeline. So what used to take a team of engineers to deploy, I think, is going to be installable by someone in a command or two, and that's going to be a real game changer, because all of a sudden, I think this comes down even to the developer, right? So you don't need to be you don't need a software architect to install Hadoop anymore, right? I mean, or Spark, that would be something. You could get to the extent you understand, the language. Maybe you don't need a data scientist. All of a sudden, you're a developer. You're like, okay, I can install this and run a job, or into whatever, connect, build this into my application in some way, and just the heavy lifting is going.
Yeah, I mean, we start to see these. We've seen this kind of with NPM and with, maybe you could say, Docker Hub. These different experiences of sharing code and making for easy package management and installation. So interesting. Okay, well, I want to talk some about this blog that you started on Medium somewhat recently. It was back in May. It's a blog called Scale. And so I mean, what are your goals with the Scale blog? What kinds of material are you trying to cover?
The goal of the Scale blog, honestly, is just to kind of, I think, keep advancing, or keep a discussion happening. What I think is a high level, kind of valuable discussion around the technologies and the businesses that are driving today's businesses, right? So
okay, so iconic of this is, like, you did an interview with Doug Cutting, who is one of the original creators of Hadoop. What were the biggest takeaways from your conversation with Doug?
Well, I thought, so with Doug, one thing I tried to focus on was just the open. Doug is an open source like guru at this point. He's done so many big projects in the open source, or at least two really important ones. And I think from Doug, I really want to talk about how these open source projects mature into businesses, and how you manage the business aspects of an open source project compared with the open source aspects and the engineering aspects of an open source project, and how how to tackle these things, right? I think
you're talking about, like, governance versus.
Yeah, I'm talking about governance, but also, like, the community wants to do one thing, a company wants to do another thing. There are, with Apache, there are trademarks involved, and some people want to call something Hadoop, but Cloudera doesn't want to call it Hadoop. And there's so many things at play. I think that again, this is very specific to the interview with Doug, but that I think people are really interested in, like, Doug's thoughts on how to do this, because everyone is doing something in the open source today, right? So many of the technologies that people use are open source, and there's just all these questions about, like, well, if I want to monetize this, what's the best way to do it? If I want to pick a project, what's the best way to look at which project's going to be around for a while, or which project is going to be right for me? If I want to if I want to bet if I want to contribute to something, if I want to bet my company on a technology, like, there's a lot to consider. And I think Doug, he's biased in some regards, obviously, but in other ways, I think he's a very good source of information about just kind of how open source projects mature, and how people should think about this aspect of their career.
Well, and one thing he said was, when he was speaking to Cloudera, he said that it was more appropriate for Cloudera to follow rather than lead, because there's such a wide surface area of places that are using Hadoop, and they all solve different problems. Like, that's, for example, how we ended up with Kafka. That's how we ended up with Spark as these kind of de facto products, and they both came from radically different places. One came from LinkedIn, one came from Berkeley. So it's really hard to know in advance where things are going to go. So I think one of the things I took away from that interview was that follow rather than lead idea. But I mean, is that how Cloudera was in the early days, or were they trying to shape the direction of Hadoop a little more aggressively?
No, I think it was very much follow. I think it's always been that way. When you look at the two things Cloudera has done, well, so you have to look at it in a couple ways. One, and to Doug's point, like, yes, it would not be prudent for a company to sit and go, look at, let's say, half a dozen projects, all do open source projects doing the same thing. Go, we're going to pick a winner, and then the community goes, yeah, we're going to pick a different winner, right? And then all of a sudden I think that's what he's talking about. You have to see how these things play out, see what the community wants, see where the development is actually happening, right? So you don't have to take it all on, and then embrace and adopt. On the other hand, Cloudera has created, I think where it really saw a need, it acted with Impala, and then with Kudu, its more recent storage system, and also even with some open source projects. I mean, the one thing that companies like Cloudera and Hortonworks and even MapR do is they go, well, we're gonna start our own open. We're going to do something in the open source to try to get this project off the ground, right? So Apache Century, I believe, is kind of a Cloudera. I hope I'm not mixing up the distribution battles here, but I mean, Cloudera has its open source security play. MapR and Hortonworks have their open source security plays, right? So it's kind of, I mean, I think they still try to shape it, sometimes in the open source and sometimes via product development, but product development is probably kind of a last resort in some regards, in some respects.
So you've mentioned security a couple times in this conversation. What is the conversation around security in the big data space?
I mean, honestly, I don't know if there has always been much of one. And today it's a lot of. I mean, today I still think as much as it's been a while, frankly, since I've spoken with people in the big data space about security. But I mean, it's I think it's still in its nascency. Frankly, I mean, you're worried about access control, authentication, that sort of stuff. But now it's getting to the point where you're worrying about, I think there are companies, Squirrel, which is based on the Cumulo technology, right, is doing kind of open, what I would say, like cell level security, right? I think there's lots of talk about encryption now. The game is just so the cybersecurity space has become so important in such a short time frame, it seems like. And, I think it's, meanwhile, the big data space has been kind of humming along and like, well, we'll solve these things piece by piece. And then not because, I mean, the goal, I think when Hadoop started, certainly there wasn't a massive security breach every day. Yeah. Right. So but I do think there is this fear of kind of, so I mean, yeah, that's just like, we now realize it's very important. I think people realize it's very important to secure data, and how are you going to do that? And I think that, frankly, one of the big challenges that all security plays have today, including the big data players, is like, data. Just there's so many endpoints at this point, right? And so many. Network security is great on the internal network, but what about when you're at Starbucks, right? Or what about your mobile phone versus your desktop versus, I mean, how many devices do I personally connect online with, right? Like, how do you, keeping track of some of these things, I think, is all the access points is one thing. And then in big data, and then when you tie in the applications of big data, the Internet of Things, let's say, right? All of a sudden you're talking not just about like, well, I'm keeping I have this data lake and I'm keeping it secure, but like, how many things can talk to that in some way, shape, or form? Like 1 million devices out there, right? So yeah, I think it's.
Yeah, and there's a podcast I actually listened to this morning. It's O'Reilly has a pretty good big data podcast where Ben Lorica interviews various people, and he was actually interviewing Ben Horowitz in this episode, and he was asking Ben Horowitz about the security stuff, and Ben Horowitz said, what companies are realizing is that it's hard to defend your data center against a nation state. China is, if China can attack, or if you think of whatever, if the nation state is referring to as China or Russia or whatever you want to call it, if they can, get into JP Morgan, they can definitely get into, any of these, some smaller company. I think the narrative that they were going at was like, was partially a discussion of the on-prem versus cloud stuff. Like when does the conversation begin to shift to cloud being safer? I think my understanding is early on in this in the discussion of cloud, like should we move to the cloud, security was like a downside risk of moving to the cloud. Now it's like you move to the cloud, you get the best security and you get to pass the buck, right? You pass the buck to Amazon. Hey, we didn't get hacked. Amazon got hacked.
Yeah. Well, I think at the first GigaOm Structure conference, I think it was someone from Sun Microsystems. So that tells you how long ago that happened, right? But someone was like, I mean, it was like not Andy Bechtelstein, someone from Sun. Anyhow, but he was like, oh yeah, the analogy was essentially, do you trust the bank with your money or do you keep it under your mattress? Like it's kind of that same sort of.
Yes.
And that was the idea with the cloud thing. But yeah, and in one regard, I think open source might be might be a boon to security in this regard, right? Because I think one thing you always hear is that the software quality tends to be higher with an open source project, just because there are so many eyes on it and so many.
Sure, people in Bazaar.
And yeah, so there are companies out there troubleshooting it, and it's just it's a very it tends to lead to a robust software product, which is one reason why its adoption of it is so much higher. It's not just because it's free, because it's never big companies pay for stuff no matter what, right? Usually, or in either engineering costs or in license costs. But yeah, I think the code quality tends to be a bit higher. But I don't know if that makes a difference, cloud versus private data center, frankly. And also, I just hear that discussion. I go, but I mean, what scares me with security, I guess, is let's say all your systems are as secure as they can be. Like as soon as you send a phishing email to someone and hook them, and then you know what I mean? And then you take control of someone's machine and you have their permissions. Well, it becomes a different story. And that's where this other aspect of big data and security comes into play, which is the huge emphasis in the past several years around like machine learning and AI for security. And this idea that, algorithms are going to be able to detect malicious behavior as it's happening, or somehow have this anomaly detection. That's and if that happened, I mean, man, that would be a big. I know there's a lot of money being invested in making that happen. I hope it works, because that does seem to be kind of the big challenge.
I think the more realistic. Well, the way that I envision this is that it's just like this latent Cold War thing where like everybody is already sitting in everybody else's infrastructure, and everybody's got a gun pointed at each other, in terms of if we're talking about nation states at least. And I think the people that would be in charge of pushing the big red button to set off the cybersecurity war don't they don't have any incentive to do that, because it would just blow up the world. But that's probably a more of a fantasy scenario. This is why I should stay a journalist, or perhaps move into the fiction, the fan fiction, big data fan fiction. Maybe that's a place to go into.
I don't know if that's such a crazy idea, honestly. Mm-hmm. I mean, especially at the nation, when you're talking about like the nation state level, or the geopolitical level,
right?
Maybe if you're talking about your credit card data. Right, I think it's a different sort of story. But.
Sure. I mean, I'm honestly I'm not so worried about like getting my credit card. Like, sure, fine, get my credit card data stolen, sync my bank account. Not a big deal. I can make back money. You can't make back an apocalyptic, blow up the world, blow up a power grid scenario. Okay, but going back to that Doug Cutting interview. So one of the things he said that I thought was really interesting was, he said he's concerned about what he called single technology companies. I don't know if you remember that part of the conversation, but what is the difference between a single technology company and the type of company that he would see as more resilient?
Okay, I think what Doug was getting at there is this idea of, so in his case, Cloudera is not the Hadoop company. It is a company that incorporates. I mean, how many open source projects does its product incorporate, right? Like 24. It's a stack, essentially. You're buying into a stack of things, a platform. I think, I would argue, I would put Mesosphere in that category too. I mean, it's not just like we're the Mesos company. No, there are many different components of this thing, right? They're all and technologies that are part of this. One of the technologies that Doug and I talked about, and I don't know if it made it into the interview or not, because it's the the flows was like Apache Flink, for example, which popped up as this sort of newer competitor to Spark.
Sure.
And I think the idea there was kind of, does it make this bet to be like we're the Apache Flink company, or because you don't know what the lifespan of that technology is.
Mm-hmm.
If Flink doesn't catch on, if Spark advances, because Spark already has this huge community behind it, do you want to make your bet on this one new technology being the thing, essentially?
Yeah.
And so I think, if Cloudera had said and any of these companies said, like, we're going to be Hadoop and we're not going to look at any other technology, that would have been a horrible idea. And, and I think that's what he's getting at. I mean, you don't want to be the, I don't even know what I think there are these bits and pieces of that floating around, these little projects or technologies where you go, it could be interesting, but at the end of the day, I mean, what is the real, like, why isn't this just a feature of a bigger platform, right? Or why isn't this just and maybe, 20 years ago, it wasn't quite the case because everything was a proprietary technology and you would buy that one thing. But today, that's not really the case oftentimes.
Yeah, we kind of are entering into unprecedented territory. And, companies like Confluent or Databricks, it's hard to imagine, for me at least, like these companies failing because the technology is just so widely adopted. But on the other hand, you could consider them, I don't know, the single technology companies. But I did have a conversation with Flavio Junqueira, who is the guy who made Zookeeper. And I asked him basically, so why did you productize Zookeeper? And I don't remember his exact answer, but I think it was something along the lines of just like, there's not a really straightforward way to do it. Like, what is the Zookeeper product, right? So
yeah, no, and I mean, listen, I think there's been a lot of discussion about Databricks, and how that's going to play out, because a lot of people, I think, look at it and say, well, okay, it's a Spark company, but so is Cloudera and Hortonworks now is a Spark company. So yeah, and I think you look at you see all this investment and all this excitement, and Confluent is probably that way too. I mean, I think Doug would say, I hope they have a platform play, right? Because you really have to,
like a lock-in thing.
Well, yeah, a lock-in thing, or just like bet on a stack of things, because God forbid, like Kafka doesn't turn out to be the thing that ultimately wins in the end. I mean, if you're Cloudera, you can go, okay, well, we support a Kafka. That's not the thing now. So now the thing is X, right?
Right.
And so I think that's what he was getting at. It's just, it becomes so risky because these things are popping up so fast that you really have to look to the future and say, okay, how can we make this a great product and make sure it is the thing if we're going to bet on that one technology.
Very interesting. Okay, well, Derrick, it's been really awesome talking to you. I could talk to you for hours, but thanks for coming on Software Engineering Daily and talking about big data. And I'm excited about Mesosphere, obviously, as you can tell by the different interviews I've done with your coworkers, and hope to keep in touch.
All right, thanks. I hope it was interesting.
Yes, it was definitely interesting.